Welcome to Lesson 2 of the USB Network Gate SDK tutorial. In the last lesson, we went over the basics of the framework and why you'll find it useful. Now we'll walk through the installation of the software development kit and start working on a basic server application that can retrieve a list of USB devices that are physically connected to your computer. In order to build with USB Network Gate, you will need to install the software development kit. There's a link to it in the video description, and the SDK comes with a 7-day free trial. You may also request a trial extension if needed. I'm going to download the appropriate version and run the executable file to complete the installation. Now that we've installed the SDK, we're ready to get started with the actual WPF application. All the example code for this project will be linked in the video description so you can easily get a head start on your own program. Starting with the blank WPF project in Visual Studio, we'll need to reference the library files from the SDK as well as the C# files that let you interoperate with the SDK. These are located in USB Network Gate's installation directory. The first file we'll need is located in the subfolder SDK Usage Samples, and it's this u2ec.dll file. We're going to copy it into the root folder of our server project. Then in the subfolder called Samples Using DLL/C#, this u2ec.cs file must be copied into our program so you can call the SDK functions directly. Our application will consist of two main parts: the model, which contains all the code classes, and the view, which is our graphical user interface. We'll start with the model. For simplicity, all the code within the model is just contained in a single file. There are three main classes we'll be working with: USB device, USB hub, and a container class that's just called model. USB device will store whatever properties we want to associate with, you guessed it, a USB device, such as name, connection status, and anything else you might need. We've set this class up to inherit from a base class called Observable Object, which provides a quick and easy implementation of the iNotifyPropertyChanged interface so that the GUI can be updated at appropriate times. It also needs to store a pointer that references the device's location in memory within the UNG framework. This pointer will be generated by function calls you make to the SDK when a device is created. We'll call that property context and add an appropriate constructor. It's worth noting that even an empty port is considered a USB device in memory. It just has a disconnected status. The rest of these properties are fairly standard, and not all of them will be necessary for your implementations. The ones down here are primarily there to provide information to the UI, such as which image to use for the device's status or what text to display for a certain connection status. You can customize these however you want. Our next class is called USB Hub, which is a container for USB device objects. It only needs to store two things: a name property and an observable collection of USB devices called ports. This will be populated with the list of all the ports available on your computer using SDK function calls later in the lesson. Finally, on to the generic model class itself. It will need to store a pointer to a USB Network Gate context, which we'll retrieve from the SDK later. We'll also give it an observable collection of USB hub objects. Since each hub contains a collection of devices, this forms a conceptual tree structure that will serve as the basis of our user interface. Now on to the view. The user interface is connected in the main window class and corresponding designer file. In the main window constructor, we bind its data context property to a new model. Then in the XAML interface design, this allows us to add a tree view user control that will bind to the hubs property of the model class. Then for each USB hub within that collection, we'll display a hierarchical data template that binds to the ports property of the hub. So we have a tree view that displays a collection of USB hubs and then displays the list of that hub's available ports and devices. Finally, let's add 3 buttons at the top of the window that let us select whether to display all the computer's ports, only the ports with devices plugged in, or only the devices that are shared. The UI template for these buttons is contained in a separate file, menubutton.xaml. We won't go over this in detail because it's not relevant to the functionality, but these act like radio buttons. Only one can be selected at a time. When the selected button changes, it updates a corresponding Boolean in the model, which changes which ports are displayed in the tree view by changing the display mode. Now it's time to actually retrieve the list of available devices. We'll create a function called rebuildTree to accomplish this. RebuildTree will first reset the display and close any auxiliary sharing windows. Then let's check whether or not we already have a pointer linked to a USB Network Gate context in the model. If there's already a pointer set, we can call the server remove enum USB dev function in the SDK, and this will remove the UNG context from memory. Then we'll set the context pointer to 0 to completely reinitialize everything and clear the collection of USB hub objects that have been previously retrieved. Next, we'll call the function named server create enum USB dev to create a UNG context. This function returns a Boolean to indicate whether or not the operation succeeded and takes an int pointer to the new context as an out argument. Next, we've got a subroutine defined here called enumerate hub, which will take a pointer to a USB hub and use that to list all ports and devices that are available in that context. The subroutine is recursive, allowing us to navigate the tree structure of USB hubs and devices. At the beginning of the subroutine, we'll set up a for loop that iterates through the available devices and adds them into the current USB hub. It does this by making repeated calls to an SDK function called server get USB dev from hub. We'll pass in our pointer to the UNG context, a pointer to a USB hub, a continually incrementing device index, and finally an out pointer variable that will refer to the newly retrieved USB device or hub. Once all devices and hubs are enumerated, this function will return false and our loop will exit. You will need to continue incrementing the device index, which in this case is the variable I. Otherwise, when we make the call to the SDK function, all we're doing is retrieving the same device over and over again and the loop will never exit. Once we've retrieved the device or hub pointer, the server get USB dev name function will yield the object's display name given this pointer. Then, to determine whether we're working with a device or a hub, we can call server USB dev is hub, which takes the UNG context variable and the retrieved device's pointer as arguments. If it's pointing to a hub, then the function will return true. And then we can create a new USB hub object and recursively enumerate all its ports. Then we add it to the observable collection called hubs that's contained in the model class. Alternatively, if the function returns false and there's already an existing hub, we can create a new USB device object and attach it to the ports property of the current hub. This forms the basis of the rebuildTree function to enumerate all devices and hubs. Next lesson, we'll add onto this function to allow for more configuration options. The last feature we'll add in this lesson will enable our application to detect when devices are plugged in or removed. This way, we can dynamically update the device list. The UNG framework defines a delegate void type called onChangeDevList that represents a callback to a function. So we'll give the model class an onChangeDevList delegate object to handle this callback. It's important to actually store the delegate in the model class and not just assign it anonymously in the constructor. Otherwise, it'll no longer be in memory when the event fires, and an error will be thrown. Then, in the model constructor, we'll assign an action to the delegate to regenerate the list every time there's a change. To register this callback with the SDK, we pass our delegate into setCallbackOnChangeDevList. This will ensure that our delegate gets fired when the underlying Windows service detects a device being added or removed. While the operating system notifies USB Network Gate immediately when a device is inserted, there can be a significant lag before the device's internal software has booted. By delaying for 2 seconds here, we allow the USB device to get started. Then we can rebuild the device tree and display it in a thread-safe manner that also doesn't force our user interface to wait. In addition to subscribing to the OnChangeDevList event, we'll also create a timer object that automatically updates the device list every 30 seconds. Now I'll build and launch the app from Visual Studio, and then once it's running, I'll plug in a USB external keyboard. It takes a second or two, but the device list updates, and sure enough, it shows up in the list. Now that we've retrieved a list of available USB devices in the system and can handle the events that occur when a device is plugged in or unplugged, we're well underway to building a fully functioning application with the USB Network Gate framework. Next lesson, we'll talk about how to actually share devices and go over some more advanced options for configuring the application.